You haven't heard from me in a day.
I figured you'd be busy with all the exams, so.
Yeah, but not that busy. Bless you. So we're creeping up on our final, which is the 29th. I better post a notice to that effect. Ain't no big thing. Not bigger than, I mean, yeah, it's going to cover new material, but it's not going to be, you know, worse than the midterm was. It's not like a super comprehensive 3-hour thing. It's just meant to be done, you know, in a single class period. And by single, I mean, you know, normal, not a double long, like we have. Oh, yeah, yeah. It's just kind of a Unit 2 kind of thing, just like the first one, except over the new chapters. That's all it is. Use your notes, use your laptop if you want, PowerPoints, whatever. August? Why don't we make that July? We're not going to be here in August. Yes, ma'am.
Do you know when the fall semester starts? Like the first day of the fall semester?
Well, that's a good question. I ought to know. Let me look. August 19th. May as well put that on our notice too. So our final will be July 29. It'll be just like the midterm. About an hour or so. Open notes and book. And idle. Etc. By the way, fall semester begins August 19th. Is that a Monday or Tuesday? Sometimes they start things on a Tuesday.
Should be a Monday.
It is. All right. So we get a precious 3 weeks of break. Well, the instructors don't, poor us. What a job, though. You do get more time off as an instructor, but then you work late hours. Whatever. So we've been talking about looping. We know that there's a different syntax. And oh, we're going to mention, if you have this problem, if you ever see this problem, something like minutes is equal to, wait, let's do a print statement. Print, enter minutes, like that. And then minutes is equal to input minutes. And then you do hours equals minutes divided by 60, something like that. And you want to print the hours. I know some of y'all know already what I've done wrong, and that's okay. I just want to demonstrate something. And lecture K, I believe. Okay, so when I run it, you're going to get, oh, that's not the error I wanted to get, but what did I do wrong? It said minutes is not defined. That's because I did something really stupid. I was spacing out here. When you're getting input, you either put nothing there or you put whatever you want to print there. And I had somebody ask what that did. Firstly, let's put nothing there and then run it. And right, we get a blank space there, or not even a blank. We could type in something. You know, if you filled in something there, like, you know, Todd, then when it ran, it's going to print, you know, Todd there. And so we just been putting the little angle there, you know, to tell people where to type. You can put a question mark. You don't have to put anything. Works just as well. Okay, so I'm going to type in a minutes. 60 minutes being 1 hour, and it blows up. If you ever see this, unsupported operand type. For one thing, it's probably going to tell you the line number that crashed. Sometimes the error is actually on the line above it. But if we take a look at it, line 3 is probably where our error is. And in this case it is. Well, how do I find my line number? There's a line number counter on the bottom if you expand it. It's real subtle. Some editors put the line numbers all the way down the sides, which is really nice. But you can just put your cursor here, you know, move your cursor up and down until you see this thing say line 3. I mean, it's obvious here, right? Because we only have 4 lines. It's real obvious what the third line is. But, you know, if you have 2,000 lines of code and it says error in line 876, yeah, you just gotta, you know, you can find it. Just put your cursor there, start paging up, paging down, then using the cursor button. Alright, so that's the problem, is that line there. Now the real thing to key in on is the error message that explains what's going on there. And sometimes it's written in, you know, such computerese that it's untranslatable, but this is translatable. Unsupported operand type. Well, we know what an operand is. It's a symbol. And it's telling us which operand. Okay, well, my division's not going to work. And then it's giving me a big reason for why that operand's not working. And it's because one of them is a string and the other one is an int. And what it's saying is you can't divide a string, which is just a series of things between quotes, letters or names or whatever, and a number. Now you may think, but I didn't enter a series of letters. I did enter a good number. But if we print out what, if we could look to see, well, let's do it inside the shell. Maybe we'll be able to tell it. Like if I do this, x is equal to input, and I type in something, and then I say x, we see those quotes around it. The quotes means it's a string. The quotes mean that we can't do math to it. We can't say 213 divided by 4. Excuse me, x divided by 4. Unsupported operand type. So if you ever see this unsupported operand type, immediately think, did I forget to convert it to a float? Or you could convert it to an int, because that's what it's talking about, but why not a float? So they can type in a decimal. An int would not support a decimal. So we just need to convert it to a float beforehand. Hours is equal, beforehand. So in front of line 3, I got to turn minutes into a float. Minutes equals float, parentheses minutes. So that's why we check the error messages. I mean, by habit, we have been doing, you know, the float line after the input line every time, but it's easy to miss it. And if you miss it and you get that error message that says, you know, unsupported operand type string / int, well, then think to yourself, okay, unsupported operand probably means I forgot to do a float. Just burn that in. So I believe this is lecture K, as I said. So the book shows a for loop looking like this. For count equals 0 to 3, step 1, we would write it in Python a little bit different. For count in range, parentheses, starting at 0, and if we wanted to go up to 3, we actually have to do it 4 because this is one past the stopping point. It means go until, or stop before it reaches 4. And then our step is 1. So that would count it from 0, 1, and 2, and 3. Sorry that that number does not equal that number. It's just Python slightly different. What this is meaning is while count is less than 4, right? Not while count is less than or equal 4. So it's not going to include the 4 in the range. What if you were going to count down? What if you wanted to count down? Yeah, we can put it in our code, right? Count down from 10 to 1. Well then, for count in range, my starting point is 10. My end point is 1, but I got to go 1 further. So it include 1, because if I put 1 there, it's not going to reach 1. And then we need to go -1 each time because we're counting down. If we put +1, it's going to try to count up, and you can't count up from 10 to 1, right? No way. It's like trying to walk up the stairs to get from floor 3 down to floor 1. You're not going to be able to get there by walking up. So that needs to be a, that needs to be a -1 here. And then a colon, since the next line has to be indented, and I'm just going to print the counter. Print parentheses count. And we're going to see that it does in fact start counting down from 10, but it doesn't reach 1. And that's because it's not doing, don't type this because I'm going to delete it, or I guess I could put it in as a comment, while count is less than or greater than or equal to 1. It doesn't do that. It leaves off the equal. So if we want to get it to work, we have to change that to a 0. Like that. Now to count all the way down to 1. There is another use of the for loop which the textbook's not going to talk about. It's for stepping through a series of items, what is known as an array of items. We are going to talk about arrays, but it's not going to talk about using a for loop to access the arrays, I believe. And that looks like this. We haven't talked about lists yet, or arrays. And in Python, those two terms are synonymous. A list of items is an array of items. Like you hear somebody say, he has an array of choices before him, if we're speaking all fancy. Right? An array of choices is a list of choices. So let's make a list of choices. We're going to make something called colors equals, and now we're going to use square braces, not curly braces. So don't hit the shift key. And between those curly braces, I'm going to list some colors, and I'm going to put them inside quotes. Open quote, red, end quote, comma, open quote, green, end quote. And I'm putting spaces here to make it real obvious where the commas go. Comma, open quote, blue, end quote. And then there better be that close brace there at the end. Now I can step through those colors as easily as I'm stepping through the counter here. Like this. For, and I'm just going to choose the word V, but I could choose the word value. Why not? For value in colors, colon, hit enter. Make sure it's tabbed over the next time. Print, parentheses, value. The way you read this is for every valid, or for each value in the colors list, print it out. So like for every person standing in line, you know, sell them a ticket, right? For each value in colors, print that value. I'm going to get real tired of typing in the number of minutes. I may comment that code out. And then it printed out red, green, and blue. So it stepped through the list of items. I am going to count out the minutes and hours and business, stuff like that, because I'm tired of typing it in each time. So I just scroll back up and commented those 5 lines out. Okay, so I'm going to add a comment above this list explaining what we're doing. The for loop can be used in Python and a lot of other languages, and other languages like C++ and Java, to step through a list, parentheses, array. And now we're going to talk computerese again, and we're going to say it's a list of elements. Like that. That is a list of elements. Can you only put strings in a list of elements? No. You can put numbers. Scores equals square brace. I like doing the end square brace immediately so I don't forget it at the end. And then I'm just going to type in some numbers. I made 100 on the first, 100, comma, and then I made an 80 on the next, comma, and I made a 90 on the next. So this is a list of numbers, not list of numbers. And now we're going to step through them. For, and I can pick whatever variable name I want. And what textbooks will show you sometimes is doing this, and I'm going to not do this for a reason that I'll state. So don't quite type this. Be prepared to change it. For scores, for score in scores. Sounds great, right? For each score in the scores list. Now what will happen though is when you start coding like that, at some certain point you're going to add an S to the variable that you're not trying to print out, or you're going to remove the S from it, and it's just going to mess up. So if your variable names differ only by an S at the end, it's not the best idea. It's too easy to make mistakes. So that's why I used value up here rather than for color and colors. I'm just going to say for V, whatever. Save myself some time. It could have been the word value, but the variable name is meaningless as long as I use it consistently, right? I could call this for Donald Trump in scores as long as I didn't put a space between Donald Trump, you know, and then print Donald Trump, and it would still print out 180 and 90. For V in scores, print parentheses V. And maybe we'll stick a word in front of it just for funsies. So print parentheses quote score equals end quote comma V. And there we go, right? We printed out the 3 elements of the list, all 3 scores in our list. Like that. So that's using a for loop to step through a list. What is a list? It's just a series of values separated by commas between square braces. And we deal with lists all the time. You have a grocery list, right? You have a list of responsibilities. You have a series of steps you got to do in order to drive your car, right? Open the door, sit down, close the door, turn the radio on, right? You know, the really important stuff. And then start the car, you know, and then shift in the back and then back up, right? You know, it's a list of steps. You have a list of songs you like on your, you know, I almost said iPod. And, you know, who has an iPod anymore? But anyways, right? List of MP3s on your phone, right? You have a list of movies on Netflix that you want to watch. It's maybe called a queue, you know, or whatever. Just a list. Lists are one of the things that computers are designed to manage because our information comes right in large series of values, right? A phone number is just a list of digits. Your text that you text somebody, right? It's just a series of characters. It's a list of characters. Step back into our PowerPoint. So the step value, the last number in that range statement, can be positive. It could be negative. If you're counting up, it's going to be positive. If you're counting down, it's going to be negative. This language has a quirk, which some other languages do not have, which is that the step value cannot be fractional, meaning it can't have a decimal point. Let's see if that's true. For x in range, starting at 0, going up to and stopping before 10, so it's going to count 0 to 9, and I want to go up by 0.5 each time. And I believe it's going to yell at me about that. I believe this is going to be a syntax error, especially if I don't put anything after the colon, but parentheses x. So I'm wanting it to print 0, 0.5, 1, 1.5, and so on. But due to a quirk in Python, I believe, yep, here we go. Java and C++ and a bunch of other languages allow you to put anything you want to in there. If you want to put in 0.00017, it'll add 0.01117. In this language in particular, you have to put a whole number there. If you're not allowed, if you really want to stick 0.5 there and it's not working, you would need to comment that out and change it into a while loop. So I am going to comment that out, and then I'm going to explain why. Python has a quirk where the step has to be a whole number. In other words, an integer. Doesn't mean Python's stupid, it's just the way they designed it. And there's a way around it, so it's not a big deal. It just takes a couple of more lines of code. So we will rewrite that using a while loop, because there's no for loop that can't be written as a while loop. So why do we have for loops? Because the syntax is a lot shorter, right? It took one line of code to specify the sequence of values we're going to do, and it's going to take 3 lines of code plus a print statement to do it with a while loop. And that's the price we got to pay if we want to put a fractional value as a step. So we want x to start at 0. So we're just going to initialize x to 0. X is equal to 0. And then we need a while loop. It's supposed to loop, so while x is less than 10, colon, we see where these numbers are coming from. 0, 0, 10, 10. Now let's print out x, just like we're doing here. Print parentheses x in parentheses. Excuse me. And then x, I could type x equals x plus 0.5, or I could type the short form, right? That's the long form, x equals x plus 0.5, or the short form is x plus equals, with no space between them, 0.5. And now we'll do the same counting. It just took, twice as many lines. That's why we like for statements. It's more concise, right? Fewer lines of code required to specify it, and in a single glance I know the bottom line, I know the top value, or one less than the top value, right? It's going to count from 0 to 9, and I know the step value if it had worked. So for statements are cool, but if it's not going to work, you can always write it as a while loop. There's another loop that you have to write as a while loop in Python, because Python doesn't have it. And it's called a do loop. And the book's going to talk about do loops, so we're going to mention it. It's just, they left it out of Python because anything you do with a do loop, you can also do with a while loop. It just takes an extra line of code. And so now we go, and it's counting from 0 all the way up to 9.5, like my intention was for that. Now, is this going to be a test question on MindTab? Nah, because they're not, you know, they're not really customizing it to all the quirks of a specific language. So in this line of code here, it would have been very easily for them to substitute a fractional step value, because theoretically it works, whereas in Python it doesn't. So if we had this here, and what is this going to do? I'm going to erase my Python version here. For count equals 0, 2, 3, step 1. Well, it's going to do 0, 1, 2, and 3. And I don't blame you if MindTab asks you how many times it's going to repeat, and then you get it 1 off because of Python wanting a 4 there rather than a 3. Just sorry about that. So if we had this, it's going to print out hello. It's not going to print out count because it's not telling it to print out count, right? It's not saying output count. It's saying output hello. And then counter is going to be incremented to 1. And it's going to print hello again. We printed out hello once and now twice. Counter is equal to 1. Then counter is going to go to 2. And it's going to print hello again. So we have 3 lines of output. And the counter is going to get incremented to 3. And it's going to print out hello a 4th time. And then it's going to add 1 to counter again. Counter is equal to 4. We're done. We stop at that point. So we printed out hello 4 times. In our language, it's super easy to figure out how many times it's going to print because you just subtract. No, I'm not going to say that. But let's see if that's true. Let's see if this is true, if what I was about to say is true. For x in range 0, 4, 1, in parentheses, colon, count from 0, stop before it reaches 4, go up by 1 each time, print hello, for whatever purpose. We're really friendly today. How many times is it going to print? I say 4. Why do I say 4? Because 4 minus 0 is 4. Let's find out if that's true. And it printed out hello 4 times. So the number of times it's going to iterate is just that number minus this number. That makes it super easy. If I put 100 there and I put 107 there, how many times is it going to print out? It's going to print out 7 times. 107 minus 100 is 7 times. Now it's dumb for me to use this setup in order to just print hello, but that is how many times it's going to print. And if I change this to hello, end quote, comma, x, in parentheses, we'll actually see the numbers that it steps through, which are going to be 100, because that's where it's starting, 101, 102, 103, and it's going to go all the way up to 106. Because of the 107 there, it stops before it hits that. So I may as well even put that as a comment. 100 through 106. And there we go, right? It printed out 7 lines of code because 107 minus 100. And if we go back to our PowerPoint, it's not quite as easy to figure it out from here, right? Because 3 minus 0 is 3, but yet it printed out hello 4 times. It doesn't say that, but we counted it out. So in a way, Python's even cooler. Still kind of bugs me. If I was going to go up to 3 in Python, I'd rather that second number be 3. But I don't get a choice. So the while statement could be used in place of the for statement. Sure can, just like we showed. The while line, the while statement and the for statements are what is known as pretest loops. And pretest loops are all we have in Python, so we're not going to talk about it much. I'm not going to talk about the other kind much. What do we mean by pretest? What if we had this? x is equal to 10, while x is less than 5, colon, print in parentheses, will we see this, in parentheses, comma, x. We're asking a question. Are we going to see this? And the answer is no. Why? Well, what if this while was an if statement? Oh, I've made a mistake already, which is why I like for loops. I always forget to add the last thing, which is to actually update the variable. The 3 steps of a while loop are one, initialize, like we do here. 2, test the word while. And then after test, there's the body, right? What you actually want to do. I'm leaving that out because you could write a while loop without a body, as long as you have the final step, which is 3, update. Now, I didn't say initialize what. Do I want to get fancy? Initialize LCV, loop control variable. And then the next one would be test the LCV. Then there's the body, and then there's the update of the LCV. Now that's a little bit too computerese, right? A little bit too programmerese. We could delete the word LCV and just replace it with the word variable, and I would like the statement better. I'm going to delete LCV because that's a little bit too techy. I mean, techy's great and all that, right? But initialize variable, see what I changed, test the variable, and update the variable. The book may call it modify. I never remember which word they use. Update, modify the variable. So there we go. We need those 3 steps, and I had forgotten, I had forgotten to update the value of x. So x plus equals 1. Add 1 to x. Now if this was set to 0, it's going to repeat 5 times. 5 minus 0 is 5. And I will see it print. Will we see this 5 times in a row? Sure enough. If I change this to 10, am I going to see anything? Well, how many times would I expect it to run? 5 minus 10 is negative 5. Well, how is it going to print negative 5 messages? That's ludicrous. So let's run it. And we don't see it print. Will we see this at all? Why? Because what if you replace the word while with if? Would it print anything? X is 10. If x is less than 5. Is x less than 5? Who's awake and watching the screen? That was just a true-false question. Yes, no. Is x less than 5 if x starts with 10? I see some head shaking no. So that's a false, right? It's not going to do it. So it would not print where we see this. Yeah, let's just change that to the word while. And again, it's not going to do it. Not going to print where we see this. The reason why is this is pre-test, meaning it's tested before the body. May as well even make a comment to that effect. Pre-test. Almost looks like pretext, right? The pretext for your actions are the things that set up your action. But pre-test. So if the test is false, the body, stuff that's indented, will not be executed. The test is done first, which is why it's called a pretest. Which is why it's called pretest. Now I'm going to show you a post-test loop. Python doesn't support it, so I'm going to put it in a comment. Triple quotes. x equals 10, and then while, colon, and then tab over, print, quote, what, end quote, end parentheses, x plus equals 1. And now I'm going to backspace against the margin, except, excuse me, that should not be the word while. It's a pretest loop, which is a do loop, so I'm going to change that word while to do, because the word while comes here. While x less than 5. If our language supported a do loop, it would look something like that. That's how it looks in C++, except, you know, it uses curly braces rather than colons. So what does this do? X is equal to 10. Do something. Print. What? Well, why is it going to print it? Because there's no test on that line, right? There's nothing to stop it. There's no gatekeeper stopping us from going inside the indented part of the code. So it would print out what? It would add 1 to it. X is now equal to 11, and is 11 less than 5? No. Okay, so then it bails out. So that's a post-test loop, meaning that the test happens after the body, and so the body is always executed at least one time, which is worth adding as a comment. Post-test loop, the test happens after the body. So the body is executed, done. The body is done at least one time. Pretest loop, the test happens before the body, so the body may not be done at all if the test is false. Just like we saw when I started the counter at x and then the statement was while it's less than 5. This is a nice syntax. You don't need it in Python because you could simulate it with a break statement. I'm not going to bother. We just don't have post-test loops. Don't have post-test loops, parentheses do loops in Python, but they can be rejiggered. We could MacGyver it with a while loop, right? They can be simulated with a while loop. Don't see much reason to actually give you the example because it requires us to use a keyword that we haven't learned, which is the break keyword. Break isn't a bad thing to demonstrate, though. Maybe we'll demonstrate the break word, not for a post-test in particular, but the break word looks like this. Let's do a for loop. For x in range 0, 6, so we're going to count 0, 1, 2, 3, 4, 5. We're going to print out 6 things, comma 1 in parentheses, colon, print, gonna break soon, end quote, comma, x, bless you. But then we're going to test it. If x equals 3, colon, make sure we're tabbed over, break. Now I haven't been adding the comments, but I think I will here. Just because we tabbed over twice. And it helps if we have our comments. So what's this going to do? X is going to start counting. Going to print, gonna break soon, 0. And then if x equals 3. Well, is 0 equal to 3? Yeah, so it's not going to break. Then it's going to add 1 to it, and it's going to do it again. Going to break soon, 1. Is 1 equal to 3? Nah, so it doesn't break. Come back up here. X gets incremented, x is 2. We print, going to break soon, comma 2. If x equals 3, well, is 2 equal to 3? Nah, so we don't step into the if statement. The break statement is skipped. We hit the end if, we loop back up. X is incremented once more. X is now 3. We print gonna break soon 3. And then if X equals 3, well, is X equal to 3 at this point? Yeah, so then it does step in here and it breaks, and break means exit the loop right dang now, no matter what the test is. So we're only going to see it print 1, 2, 3. Gonna break, well, 0, 1, 2, 3. You can see that this is actually kind of a post-test loop, right? Because we have a test here after the body. Break means exit the loop right away without doing another test. Now, I'm not going to ask you all to flowchart a break. I used to do that, but the flowchart doesn't really follow our rules that we've established previously, so we're going to just skip flowcharting breaks. And maybe you can see that that's actually a form of a post-test loop because the test happens after the body, which was going to printing that out. So we can use a break to simulate a post-test loop. But right now we're not going to do it. We don't care. Just know what a post-test loop. Answer the question about it on the quiz, on the MindTap exam. Not going to be on my exam. Would be if we were learning Java or C++, a language with it actually in there. Alrighty. We can use a break to simulate. Let's go to the next page on the PowerPoint. Post-test loop. Do, paying the bill, while more bills remain to be paid. Why not just write that as a while loop? While there are more bills to remain to be paid, pay the bill. That's how I think of it. While my job isn't done, do it. Right? Rather than do my job until the job is done. All right. Pre-test. Do the test first, then the body. Post-test. We're coming down here. We do the body first, and then we do the test. Not going to ask you to flowchart that because it's not in Python. This is what we got. So, recognizing the characteristics shared by structured loops. The loop controlling evaluation must provide either the entry to or exit from the structure. Well, that's a long sentence. The loop controlling evaluation must provide either the entry to or exit from the structure. The loop control here, don't like that flowchart, it's got A repeated twice. The loop control structure is the only way in and out of the loop. And the loop controlling evaluation provides the only entry to or exit. Well, seems like that's saying the same thing. Some languages support the do until loop, which is just another form of post-test loop, rather than do while. So, common loop applications. Use a loop to accumulate totals. Always got to use the fancy word. Accumulate. We're going to calculate a total, right? The total of all the numbers between 1 and 10. The total of every bowling score, right? Totaling of every test score, whatever. So if you're going to do that, you have to have an accumulator variable that gathers the totals, right? Total bowling score has to begins at 0. Unless you're really awesome and for some reason you get a bonus. I don't know why that would be. Maybe you take your kid bowling and you want to give him 50 points bonus. I don't know anything about bowling. Done it once. And then it's similar to a counter, except it doesn't go up by 1. or up by whatever value you type in. Instead, whatever that value is gets added to the accumulator. Like this. Let's go back here. And you know what? I probably demonstrated this last week, but we're going to do it again. We're going to add all the numbers between 1 and 10 to calculate a total. And the mathematical term for calculating a sequence of sums like that is called summation. So we're going to do a summation add of the values between 1 and 10. And there's a key on your fancy $100 calculator that you bought for physics and then never used again for summation. It looks like an E, except it's a little bit fancier. Sigma, I think it's called, with the bent sides for the E. And you would, no, maybe I'm misremembering. Maybe it's a curvy S or something. I don't remember. Anyways, so we need to initialize our accumulator. How about just the word total? I like the word sum, but it lights it up as purple, telling me that I should not use that word. So, got to initialize the accumulator. Because how could I add to a total if I don't have a total? And then for x in range, I want to start at 1. I want to go to 10. So what am I going to put after the cola? The comma. What have we said about the relationship between the endpoint here and the upper limit, the upper bound that we want there?
11.
Yeah, 11. Perfect. And we want to go up by 1s. Colon. And then total equals total plus x. Short form, total plus equals x. We could even print out the total as we go along. So, still indented, although later I'm going to unindent it because I feel like we only need to print the total once. Print parentheses, quote, x, comma, total. Just so that we see the numbers, right? So we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, followed by the total at that particular point. And then how about end 4? Been sloppy about adding my comments. Gonna run it. And there we go, right? After 1, the total is 1. And then we add 2 to it and it becomes 3. And we add 3 to it and it becomes a 6. And we add 4 to it and it becomes a 10. Not that this is important, but you've seen this shape before. Right? And if you were going to add them all up, 1 plus a 2 plus a 3, there's 6 circles in that triangle. If we kept going, right? 1 plus a 2 plus a 3 plus a 4 is 10, and so on. So the summation of 1 to 4 is 10. We went up to 10, so the summation is 55. I don't want to see the total every time. Maybe I'll comment that out. And, just comment that out. I don't know. Maybe you like seeing it. And then print parentheses the summation. Let's get all mathematical. The summation of 1 to 10 is, end quote, comma. I'm going to make a mistake and then ask you what's wrong with it. Summation, in parentheses. Looks good, but it's not. What did I do wrong?
Summation.
Yeah, summation is not declared. So if I run it, it's going to tell me not defined or whatever word that it uses in the syntax error. Not defined. Name summation is not defined. If you ever see the word is not defined, you probably made a typo in it, or you completely glitched and used the wrong variable name. So I'm going to replace that with total. And there we go. The summation of 1 to 10 is 55. Now there's another common series thing where you multiply them all out. 1 times 2 times 3 times 4 times 5. And that's called factorial. Fastest way to calculate a factorial would be just to copy paste and then change a word. So I'm going to copy these 6 or 7 lines of code and change the word summation to factorial and then make 2 other changes and we're done. Now I'm not sure if we learn as much by copying and pasting, but it saves time. Alright, so factorial, this is my comment now, factorial, which is multiply of the values between 1 and 10. Now I'm going to make another mistake just as a little thought problem, but it's not adding it, so it's not plus equals, it's times equals. So I change that line. This line has become changed. You don't have to add that comment. I'm just putting it there so you see what I needed to change. And then this line, because it's no longer a summation, it's a factorial, which is the exclamation point on your fancy calculator. Alright, this is almost perfect. There's one more change I'm going to need to make. Tell you what. Well, I'm going to wait and uncomment that line once I start debugging. Why am I going to debug? Because I get it wrong. The factorial of 1 to 10 is not 0. But dadgum, what did I do wrong? Well, I know because I made the error on purpose. But if I did not know what the error was, I would want to print out the total and the value of x each time so I could, watch the values increase or not increase at this point. So I'm going to uncomment out that line. I'm uncommenting the print x comma total just as a debug step. Debugging means I'm trying to figure out what's wrong with my code. And once this runs, it may be obvious what's wrong with it. Alrighty. Well, I don't know if that helped me much. But total never changes from 0. If we go back and look at the code, why does total never change from 0?
Multiply by 0? Or?
Yeah, we're multiplying by 0 every time. 0 times 1 is 0. Times 2 is 0. Times 3, right, it's a big waste of time. So we need to start our total at 1 for multiplication. Start at 0 for summation, 1 for factorial, parentheses multiplication. Good job, y'all. And there we go. Factorials get very large very quickly. You notice that after only going out to 10, we're already at 3 million. What if we double this by going to 21? I'm going to change it back. Just a little experiment. It's humongous, right? Summations don't get huge like that. If we change the summation to 20, and again, I'm going to change it back. So I need to change that to 21, so to stop at 20, right? Now that's no big deal, right? 210 is not that huge. So the summation of the numbers 1 to 20 is 210. All right, change this back. Just a sec. You remember how deaf I am, so let me pause. So a summary report contains only the totals with no detailed data. The loops are processed, but the detailed information is not printed. Well, that's kind of like what we did here. When we ran our code, unless you left those print statements uncommented, well, whoops. That's not a summary report. It shows all the steps in between. So I'm going to comment that line back out, that final print, well, not the final print statement, but the final print statement in the body. And that is a summary report. Well, why bother with a summary report? I like seeing the details. Well, if you were calculating the census information for Oklahoma City and, trying to calculate all the low-income people versus the high-income people. When there's 2 million people in Midwest City, you'd have 2 million lines of data being printed out. You don't want to see that. You just want to see the total. But you have to pick, right? If you're adding up all the sales, it's nice maybe to see all the sales, you know, for the month. But, you know, probably not if you're working for a giant chain like Walmart who processes 1 million sales a day. Conservative estimate. So that's a summary report. Only the totals with no detail, and the loops are a process, but detailed information is not printed. And both of our summation and our factorial loops were summary reports. The 3 steps for accumulating. The accumulator has to be set to 0. The accumulator is altered once for every data set, and then at the end of processing, it is output. We could add those if we don't already have them in there. Yeah. We mentioned the summation, but we didn't actually mention that we were using an accumulator. So, accumulator, which is what we just did twice with summation and factorial. 1, you create the accumulator variable. Total is a perfect word, right? I like the word total. And then 2, they're calling it the detail loop, I guess. In the loop body. Let me go make sure exactly if their syntax they're using. Oh, they're using data set. I don't like the way they said it. Anyways, the accumulator is modified based on the data set, whatever the data is, right? Whether it's just a range of numbers or it can be more complicated. It can be opening a file and reading off all the numbers in the file. And then after the loop, the accumulator is, what word did they use? Output. And we did those 3 steps. Here's our accumulator variable. The total equals 1 is our accumulator. Inside the loop, the accumulator is modified. And then after the loop, the accumulator is output. And why not mention the summary report? If it's a summary report, you only do the final output and not the details in the loop. Everybody done typing all that? Wave your hand if you need a minute more to finish typing. All right. So, month-end sales report. Here's the address and here's the price. That's everything we sold, and we print the total. We may as well simulate this. We may as well do this, but then it's going to be annoying every time we run, you know, to have to type in 3 or 4 addresses and their sales prices. So we might comment it out afterwards, but it's worth doing. And what is our loop going to do? It's going to ask us for the address. Then it's going to ask us, and when I say it, the program, is for the price. And it's going to update an accumulator with the total price. Then it's going to come back and ask us again, you know, for another address and for another price and another address and another price. And we could make it, if we wanted to where, like, how do you stop the loop, right? You type in -1 for the address, or you type in quit for the address, right? We could get fancy like that. But this time, let's just make it so that we're going to do 3. Right, so we're going to use a for loop to ask for 3 addresses. Is that realistic? Not really, but let's run with it. So, we are going to need an accumulator. Total is equal to 0. If I forgot that line, then the total sales would equal the last total we calculated, which is 3 million. So, not a good thing. For X in range, I'm just going to do 3 here. What does it mean if I leave off the first number and the last number? It means start at 0 and go up to 1 less than 3. 0, 1, and 2. Rarely do I leave those starting and ending values off, but you're going to see a lot of code on the internet if you go and look where they only specify 1 values. So this is 0, 1, and 2. You leave off the first value and you leave off the third value. If you leave off the first value, you can't add the third value. So don't try to put 3, 1 here. Not going to work because it's going to think you're starting at 3 and going to 1. Alrighty, let's ask them for the address. The whole word address, kind of long to type, but it makes it pretty clear. Address equals input parentheses quote. We're doing something a little bit different. We're not putting the print statement above it. We're putting it right inside the input. What is the address? Question mark, space, angle, end quote, in parentheses. Alright, we've already got the input, and we do not try to turn that into a float because it's an address. How can you turn 123 South Main into a float? Well, we don't do that. Next time we're gonna. So then price equals input, parentheses, quote. What did that address sell for? Question mark, space, greater than, end quote, in parentheses. Is a greater than necessary? No. Just showing them where to type. Now we have a price and we want to add to the total, but price is not a number yet, and it better be. So we do have to do the float thing, even though I did not put the print statement above the input, I put it inside it. And when I say I put the print statement, I didn't put the word print here. Didn't do that. Okay. But I put the message to be printed there. The message to be printed didn't just have to be a greater than sign. It could be a whole sentence, a whole prompt. All right, we got to convert that to a float. Price equals float price, because it has to be a number before we can do the next line, which is to add it to the accumulator. Total plus equals price. Now outside of the loop, which I'm going to indicate with end for, we're going to print what the accumulator reached. Print parentheses quote total sales colon end quote comma total. Now since this is X in range 3, which means 0, 1, and 2, it's going to ask for 3 addresses. And like I said, we may wind up commenting that out just because I don't want to have to type in 3 addresses and 3 prices every single time we run this program, run our test program. All right, what is the address? 123 South Main. I get the idea that that didn't quite work. It put it in the wrong place. Let's try that again. What is the address? 123 South Main. What did that address sell for? 90,000, so 90000. Better not put the comma. What is the address? I don't know. 456 Wood Street. It sold for 80,000. The third address is 987 Easy Street. And on Easy Street we sell for a lot, 200,000. And there's our total sales. Could we format the total sales so that it started with a $sign and had 2 numbers after the decimal point? We could. That'd look nicer. Makes things more complicated. I think I'll leave that out for now. Let me bring back the code now. But you see what we did. We asked for input. We asked for the sales price, and we used the sales prices to drive the accumulator to calculate a total. We could have done the same thing for like daily sales, right? Monday through Sunday or something like that. We're just about at the end of this. So is this a summary report? Nah, not really. I mean, yeah, it's got a summary at the bottom. But according to their definition, a summary report does not contain the details. We could turn this into a summary report by just not printing, or, you know, I'm not going to even go there. So what can you use a loop for? To validate data, right? What does that mean? Validating data is what's known as defensive programming. There are other terms for it. But making sure the data is reasonable. If you're asking on a form for somebody to report their income, you probably don't want to put in your database that they typed in zillions of dollars, or that they typed in negative zillion, or, you know, maybe you don't want to allow any data to be processed if they said they have no income. Now, you know, in reality, that's true. They can have no income, right? But maybe it would mess up your accounts if you let them type in, you know, empty data, right? They did not put a birth date in. Our form requires them to put a birth date in, you know, or a social security number. Now that's maybe not realistic if you're going to be supporting people without social security numbers. But anyways, you can qualify the data using defensive programming. Means that you're validating the data to make sure the data falls in acceptable ranges, like the month values between 1 and 12. What data are we going to insist is correct? What if we make a guessing game and we want to see if they get the right number, but we're going to make it so that it's guess a number between 1 and 100. And if they type in a number that's not between 1 and 100, we're going to force them to. What do I mean force them? We're going to keep asking the question until they get it right. Right? Just like on Amazon, if you enter a bad, you know, credit card, or the credit card is expired or whatever, right? They don't just let you press, you know, the submit button, the order button, and have it work. Instead, they force you to correct the credit card. So let's do defensive programming. Defensive programming. There's all sorts of defensive programming, but using a loop to validate data. Don't let the user enter bad data. In this case, outside of a range. So let's tell them what we want. we want a number between 1 and 100. So let's use a print statement to ask for that. Print parentheses quote. Please enter a value between 1 and 100. End quote in parentheses. Value equals input, parentheses, quote, greater than, end quote, in parentheses. Now we're going to add a while statement. And we're going to use an OR. I think I said a while back that if you're going to check within a range, you use AND. If you're going to check outside of a range, you use OR, right? So if the value is less than 1 or the value is greater than 100, it's invalid and we need to print a message. So if, which we're going to change to while in a minute, value less than 1, less than sign 1, and then the word or, and just for those of y'all who are going to go on to other languages, you'd probably replace the word or with, and don't type this, 2 vertical bars, shift backslash, okay, I backspaced over that, or value greater than 100, colon, we're going to print an error message. Print, parentheses, quote, the number needs to be between 1 and 100, in parentheses, end quote. Let's go back up and comment this address business out so that we don't have to enter 5, or 3 addresses every time. I'm going to come up here, and above that last total equals 0, I'm going to do 3 quotes there. Oh, well, let's show you another way of commenting out code. If you're using idle, if you're using something else, just use a triple quote there and use a triple quote there. But there's another way of commenting out stuff. Highlight the lines you want to comment and then use the format menu. Format comment out region. Looks different, right? They red texted it rather than green texted it. But then if you ever want to uncomment it, you can do the same thing. You highlight it all and you choose format uncomment. But I kind of liked it like that. All right, so back down here. Now we've told them the number needs to be 1 and 100. We better let them type it in again. Right? Otherwise just yelling at them and then stopping is kind of dumb. Right? Amazon, we make a $5,000 order but our credit card is wrong and so they just quit the program at that point rather than letting us correct it. Well, they'd lose the sale. So I'm going to highlight those 2 lines of data and just comment them. Not comment them, copy them. Edit, copy, and I'm going to paste them, but they better be indented under the if. So after I paste them, I'll have to fix the indentation. So I pasted them, but they weren't indented properly, so I indented them. Now I'm going to test it out. So enter a value between 1 and 100. Well, I'm going to get it wrong. Well, first I'll get it right. You should always test it 2 ways. One is to get it right and the other is to get it wrong. Okay, 90. Okay, I blew up. We've seen this error several times today. I want somebody to tell me what not supported between instances of string and int mean. What did I do wrong? It was like almost the very first thing I did in the lecture.
Float.
Yeah, I didn't turn it into a float, so it can't compare it. So after my input statement, pretty much after every input statement, unless it's asking for a name or an address or something non-numeric, this needed to be value equals float parentheses value, just like always. And I better have that here as well. It should have been one of the lines I copy pasted. So value equals float value. All right, there's still one more thing I'm going to correct, but this is 90% right. And by the way, I didn't mean to make that error. I wish it would do the conversion automatically. And in the C++ language and in the Java language, you can make that happen. Python has much cleaner syntax, but sometimes you have to do an extra step. But in those languages, sometimes you have to do an extra step or 20 extra steps. All right, so enter a value between 1 and 100. I'm going to get it right the first time, 92. Great. For whatever reason we needed that, we have it. Let's run it again. Type in something bad. All right, enter a value between 1 and 100. Negative 99, right? It's bad. It yells at me. The number needs to be between 1 and 100, you fool. Please enter a value between 1 and 100. Okay, great. 9. One more time, though. I need to see what happens if the second time I enter bad data, it behaves correctly. Run module, or run whatever. Enter a value, negative 99. The number needs to be between 1 and 100. Okay, well, I'm stubborn. I'm still going to enter bad data, 120. And it accepted it the second time. So we did a little bit of validation, but not enough. To do data validation, we ought to loop. We need to change that if word to a loop. That way they have to type in good data. So I'm just going to change that word if to while. Enter a value between 1 and 100. I'm going to get it wrong. I'm going to get it wrong a second time, right? It's not letting us proceed until we give them the right value. Just like a password program, right? You know, enter your password and you keep typing it wrong. And after a while, your account gets locked. We could be keeping track of the number of times they failed to enter good data, right? And then tell them account locked or whatever, if it was a password or ID kind of thing. Oh, I didn't test it with a good value. Always test it to see if you can make it fail. Always enter bad data and good data. As programmers, we like to test it to make sure it works. So we always enter good data. And then the customer always manages to mess it up. Okay, so that's working. For whatever purposes, we needed that 99. I guess we could add a print statement underneath it just to show that there was something successful happening. But I better not put it in the while loop because I don't want it to print success every time they enter bad data. So I'm going to back tab and do print, parentheses, congrats, you managed to follow instructions. We're kind of sarcastic, aren't we? There we go. All right, I typed in 100, I got congrats, you managed to follow instructions. All right, gang, I talked big for a while. Your turn to do something. Write a loop that will print, I love coffee, change it to hate, you don't like it, 10 times. So I would just use a for loop and indent it inside the for loop. I would have a print statement, I love coffee. I want to see I'll do that. If you can't do it, that's fine, but it's better if you can. All right, so some people did it with a while loop, some people did it with a for loop. I suggest for loops anytime you loop if you think you can get away with it because it's easier. You know, there's 2 less lines of code. You don't have to initialize something and then update it afterwards. Now Madison did something cool. I might show it to you, but I don't want to run with it at the beginning because, you know, it's an extra line or code or 2, but it's an awesome way of doing it. But anyways, for x in range, and then I was showing Anna this, and then I backed off from doing it because it's showing a way that we've only done once. For x in range 10. That's where I was going. And what that would do is it would iterate x from 0 to 9, which actually is 10. 10 times, right? If we start counting 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the only way I can do is with my fingers, right? I used up 10 fingers counting 0 to 9. So if you want something to repeat a certain number of times and you don't actually care what x is, you're not adding it to anything, then that's the short form of doing it. But I've been showing you all this, right? Start at 1 and then go, you know, up to 11, so it'll stop at 10, you know, and then go up by 1. Either way is fine. All right, and then let's print. I love coffee. End quote in parentheses. And that's enough. That'll do it. If you needed a while loop, you had to if you wanted a while loop, you initialized x beforehand and you had a while, and then you had to update x at the end, right? X plus equals 1. All right, and that did it. Show you what Madison did, which is pretty cool. She did this phrase, and this tells me that you have a career in programming coming up. I love coffee. And I'm probably going to undo this just because it's more complicated. I mean, it's not that much complicated, but if I asked you to do an assignment, I wouldn't expect you to do it this way, right? But there we go. Phrase equals I love coffee. For x in range 1 to 11, it's going to print out the phrase. The code's going to behave the exact same way as it did before. So why do it that way? That's extra work. Yeah, but there's something called localization. If you write a program, an app, and it sells, you know, millions in America and Britain, and nobody's buying it in Germany, it's probably because it's not translated into German for the Germans to use. And so what people do is they design their program so that it can be, quote, localized. What does localized mean? That all the sentences are translated into German, the numeric symbols for money are translated into whatever language, you know, yen signs or euros or whatever, you know, British pounds. And so what they will do is they will put all of their phrases, and like I said, don't be following along. They will put all of their phrases up at the top, or probably even inside a data file, so that they can easily be changed. And if I want to send this, you know, to someone who speaks Portuguese, all I'd have to do is rewrite that in Portuguese and all the other phrases. I could put every phrase I've entered here in a variable, right? Gonna break soon, that could have been a variable. Phrase 2. You know, enter a number between 1 and 100, that'd be phrase 3. And I could put all of those up there. Now I'm going to hastily do some undoing. But it's not a bad idea at all to separate what you are presenting from the code. And what do I mean by that? Putting the stuff that you're going to be printing inside variables up at the top of the program so that they can be translated into other languages. Not a bad idea at all. But I'm going to undo what I did. Why? Because I want it in the simplest form. If I ask you to do it in homework. where are we going to go next? Let's go look at the PowerPoint. Garbage in, garbage out is a phrase meaning, or GIGO, anyways, GIGO stands for garbage in, garbage out, meaning that if you type some garbage into the program, if you type in valid data, it's going to get erroneous output. Now, what the Americans invented computers for in the 1940s was to perfect weapons, you know, build atomic bombs and to create artillery calibration tables and stuff like that, right? What the English used them for is to crack codes. You know, the Germans had a code called the Enigma Code, which was created by a machine, you know, that chose all sorts of things and made the messages that they were sending, you know, almost impossible to crack. And the key word is almost. You know, and they wrote it, you know, a program that would actually be able to crack it, you know, crack those codes so that, you know, you could tell that the Germans were saying, you know, invade Dunkirk at dawn or whatever it was. But what if you type that code in wrong, right? What if, you know, you were getting some code over the radio, you know, and somebody was transcribing it and they kept leaving numbers off, right? You know, or leaving letters off. And then you type that into the machine, you get bad output, right? In order for it to be decoded, you have to have the input correct. In order to create those calibration tables or to calculate, you know, the rate of, you know, atomic decay or something like that, if you enter a bad value for how fast, you know, uranium will decay or something like that, you know, your bomb doesn't work. Whatever, garbage in, garbage out. You validate your data, making sure your data falls in acceptable ranges. Limiting a reprompting loop. Reprompting can be frustrating to a user if it goes indefinitely, right? They keep typing numbers. I guess they can't read that message, right? 1 to 100. You can maintain a count of the number of reprompts, right? We're only going to let them type in bad numbers 10 times before we just arbitrarily pick a value, you know, so that we can run from there. Now that arbitrarily thing kind of worries me, right? You know, if we're asking for their age and or their birth date and they keep typing in invalid birth dates, do we really just want to give them an arbitrary birth date of June 1, 1980? I don't know. But under certain circumstances, this is a good idea. Type in your account name and password. You might want to lock the account after 10 attempts, or, you know, usually programs are even, you know, harsher than that. So you have to keep a counter of how many wrong pieces of data they have entered. If we were going to do that, it would look something like this. And again, I'm going to undo it. But up here where we were asking for enter a value between 1 and 100, we could initialize that, create a counter that would keep track. And so I could put a counter here. I'm gonna delete this, I swear. We could set the counter equal to 1, or attempts equal to 1, and then we could set attempts plus plus or plus equals 1, right, every time they type in something bad. And then if attempts ever gets greater than a certain value, we print an error message. Print, gosh, you can't do it, can you? And then we might exit the program, right? Something like that. Maintaining a counter of bad pieces of data and then taking some behavior, whatever that behavior is supposed to be, based on if they exceed the limit. And I'm going to delete all that. Again, I like the examples to be as clean as possible, so that when you get home, you're looking at 5 lines of code rather than 17. So validating your data, you might want to make sure that what they typed in is numeric before you keep running, right? Because if they type in a word when you ask their age, not cool. You'd have to reprompt them. Our program crashes if they type in something non-numeric. If they type in letters when we want numbers. There is a function built into Python, and actually in just about every language, although it's a different function, right, based on the language, called isNumeric to check to make sure that what they've typed in is a valid digit or series of digits. Now, unfortunately, isNumeric has a couple of flaws in it. I mean, not flaws per se, limitations. The limitation is it doesn't count a minus sign as being a digit, so the user can't enter a negative data and have isNumeric work. And it doesn't accept decimal points. You could write a more sophisticated version that would let them enter a minus sign and a decimal point, but then you have to do some more sophisticated checking, right? The minus sign can only be in the beginning, and there can only be one decimal point, right? So, you know, writing your function to do all that, you know, yeah, we could do it, you know, with a little bit more learning. But let's go ahead and use isNumeric to test something to make sure that they typed in a number. Realistically, we should put it in a while loop, but, you know, that took, you know, 6-10 lines of code to do. So how about we ask them their age, print, what is your age, parentheses, whole numbers only. So for that one really picky person who likes to say they're 33.5 years old, they're out of luck. Now we're going to get their age. Age equals input, parentheses, quote, angle, end quote, in parentheses. I swear I wonder what Ken's going to do, Ken Dewey, when y'all get into his courses and you're doing that input all with that angle. Just blame it on me. Alrighty, and now we're going to check to make sure it's numeric. We want to make sure they didn't enter garbage. If they entered a minus sign, I guess we should have told them a positive value, right? But, you know, how many people try to trick the program by typing in a negative age? So, if age dot, and we haven't used this dot syntax much. About the only time we've used it is for the turtle. Turtle dot forward, turtle dot left, turtle dot right. But if age dot is numeric, parentheses in parentheses, colon, we're going to do some good stuff, right? What do I mean by good stuff? We could convert it to a float, you know, and do some math with it or whatever we need to do with the age. Print. Okay, now processing age. We're not going to really do anything with it, but we could. We could convert it to a float now, or an int, because it's valid data. It is numeric data. But if it wasn't numeric, they typed in garbage. And so we're going to tell them that. Else, colon, print, sorry, I wanted a whole number. So I'm going to add some comments here as to what's going on. Is numeric checks to make sure the string contains only digits. Limitations. It doesn't allow hyphens and decimal points. So doesn't work with negative numbers or fractional numbers, numbers with decimal points. All right. Okie doke. Let's test it. we're making our program require too much input, remember you can always go back and comment out the stuff about the addresses and the price. Run module. Enter value between 1 and 100. Why not enter good data? What is your age? Whole numbers only. I'm going to enter good data. I'm 9. And it blows up. String object has no attribute, is numeric. And that's my fault because I typed the example in from the book. And guess what the book isn't showing? They're not showing Python. I better change is numeric to is digit. And not an uppercase N. I'm sorry, that was a total flake. I just saw it on the PowerPoint, and so I typed it in. Is digit, all lowercase. And fix that in your comment, too. All right, it says, okay, now processing age. Because it was a digit. Now I'm going to type in some bad data. Run module. 1. What is your age? About 30. Well, about 30 is not good data. I can't do math on it. So it says, sorry, I wanted a whole number. Well, in other words, without any letters in it. Okay, so is digit qualifies the data. It helps validate the data. Not a bad thing to do, because if we had called float on age and they typed in about 30, then the program would crash. So within the limits mentioned down here about decimal points and negative signs, it wouldn't be a bad idea to do that. And we've already proven that we could put this kind of thing in a while loop to keep running until they type in something that's good. But short examples are good. There are other things you can check for too. Is the data all in uppercase? Is the data all in lowercase? Is the data a letter? Now, why would you care? Well, what if it's one of those things where you're asking for, a new password, and what are the rules for a new password? Quite often it's like it must be 8 characters long, or 8 long. It has to have an uppercase letter and a lowercase letter, and it has to have a digit, and it has to have a punctuation symbol, right? And no spaces, right? Those are quite often the rules for creating a password. And you can use these kind of functions to do that, right? You'd have to step through it letter by letter, though. You'd have to find out if any letter in it is not uppercase, or any letter in it, or that you found one uppercase letter, or you found one lowercase letter, how many digits you found, how many punctuation you found, and all of those values would have to be greater than 1. We may write a password validator. So, why is digit good? We can validate the data before calling float on it, so the float function doesn't crash. I'm going to list the other functions we have available, even though we're not going to use them right now. Other Python functions include is upper, is lower. I forget if it's is alpha or is letter. I'm going to Google that up. Python is alpha. Doesn't look like it. Is letter? I think it's is alpha after all, meaning alphabetic character, right? Yeah, okay. So functions include is uppercase letter, is lowercase letter. It would return false, right? If you called is upper and it wasn't an uppercase letter, or if it was a digit or a punctuation. So is upper, is lower, is alpha, is alnum, meaning it's not a punctuation, but it's a letter or a number, right? And is white, or maybe it says white space, right? Height, let me make sure that's correct. Is white. Okay, excuse me. Good, it's is space. I didn't like is white. That was kind of is space. That makes sure it returns true if the string is all white space. And what is white space? It's the space bar, it's the tab, or the /n. Right? All of those count as white space. Anything that's not, right, letters, numbers, or punctuation counts as white space. And last comment, we could write a password validation program. Example, must have upper and lowercase letters. But we won't right now, using these functions. That's something for another day. So common loop applications validate the reasonableness and the consistency of the data. Consistency, I guess, is to make sure that nobody says that their age is more than 140. Optimistic, right? Or less than 0. Lots of data items can be checked for reasonableness. I'm sure you've used that machine at the post office where you're typing in an address and, you know, it tries to clarify it for you, right? You know, you type in 123 South Main and it says, is this the right address? 123 South Main Street at zip code blah, 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 right? It tries to validate the data for you. And you can say yeah, or you can say no, I know better than you, and I'm going to just type the address in my own way. So good defensive programs try to foresee all possible inconsistencies and errors. Now sometimes that's just flat out impossible to predict. Like, maybe you've gone to McDonald's and they have the machine where you can make an order, right? And so one time some smart aleck said that they wanted a burger, and you can add and subtract items from it. And so they said, I want a burger with no cheese, no vegetables, no meat, no mayo, and no bread. And it crashed, right? Crashed their network because you can't make a burger, because after all that, there was nothing left. And so there's a picture of the error message, right, that they got that crashed that machine. I'm sure that they were a programmer who did that, and I'm sure that they felt really, you know, really happy that they managed to crash the, you know, that McDonald's little food network program. But anyways, you can't foresee everything, but you can foresee a lot. And then you can change your program if you see people making mistakes. The zip code has to be exactly either 5 digits long or 9. Maybe you know your own 9-digit zip code, right? The 9-digit zip code pretty much isolates it right to your house, right? So if my zip code is 70337-1234, that's pretty much telling the postman exactly which house I'm at. And if you know your 9-digit zip code, you could probably even leave off the state and the city and maybe even your address, and it would get to you, right? But Most people don't use 9-digit zip codes. Most people use 5, and you can make sure that they enter 5 digits, right, for their zip code. You can loop until they enter 5 digits. If it's only 4, it's not a valid zip code. If it's blank, it's not a valid zip code. We may as well put a comment about defensive programming. I guess we should have started green texting this. Defensive programming. Trying to make sure the data is valid. Parentheses. Zip code is exactly 5 digits long, or 9, since I talked about it, right? Or that the address is in the database, or that, right, whatever, that they didn't enter a letter in a number field, that kind of stuff. Trying to stop the program from crashing if bad data happens. So you're writing a video game and you write some functions to give to somebody else to display something on the screen. And then some other programmer gets your code and they try to display something, but they specify something with a negative location on the screen. Are your functions going to crash? Well, if you wrote it a certain way, maybe they would, but defensive programming would mean that you modified your functions in such a way so that if they entered negative data, it just wouldn't draw it, right? It was off the screen, or might be partially on the screen. So that would be an example of writing some functions with defensive programming, making sure it doesn't crash. I showed y'all the Pac-Man screen, right? Yeah, so, you know, defensive programming would have meant that they validated that the level number was a valid level number, that they didn't get past 255. I don't know what should have happened. Maybe the game just ended to send the player home. You know, hey, you've played for 10 hours, you need to stop. Or, you know, reset it back to 1 so that they can do it all again, or whatever. You'd have to pick how you want to handle the situation like that. So our summary. Loops allow you to write one set of instructions that operate on multiple pieces of data. Right? One set of instructions. We asked for their address and the price one time, but it worked on multiple pieces of data. We let them enter 3 addresses with, you know, one set of code. Or we let them enter, you know, 1,000,000 addresses with one set of code if we change the parameters of our while loop or our for loop. So 3 steps must occur in every loop. You have to initialize the loop control variable, LCV. I'm going to undo that. You have to compare, you have to do your test, and then you have to alter the variable that controls the loop. There are nested loops, which are loops within loops. We've talked about those. Just like you can nest if loops, if statements inside if statements. You can nest anything inside of anything. You can put sequence inside of an if, you can put a loop inside of an if, you can put an if inside of a loop, right? You can put a new if inside of an if inside of an if. So nested loops maintain 2 loop control variables. And I think we did a demonstration of that, like counting a multiplication table, and so we had a row and a column, or printing a minute counter, where we did hours and minutes. Is that sounding familiar? I did do those demonstrations. Somebody who was awake on Wednesday nod their head or shake their head. What are you talking about? Did we do a multiplication table or an hour and minute counter? Yeah, okay. So that was a nested loop. The inner loop was incrementing the minutes, and the outer loop was incrementing the hours, so that it could say 115, 130, 145. Those were the minutes going up. And then it added 1 to the hours, and it reset the minutes back to 0, so it'd print 2 o'clock, 2:15, 2:30, 2:45, and so on. Common mistakes made by programmers. Neglecting to initialize the loop control variable. Remember our total got to 3 million, right, after the factorial? And then we started adding prices to it. Well, if we had not initialized that total back to 0, then it would have shown that all the prices added up to 3 million plus whatever they typed in. Now, if I'm earning, you know, commission, I might have thought that was real cool, but no. Neglecting to alter the loop control variable. Forgetting to do the x plus equals 1, or the counter plus equals 1, or something like that. That's why I like for loops, is you don't have to remember to do that. Using the wrong comparison, right? If I say x less than 10, and I needed to make it less than equal to 10, that's the wrong comparison, and it might process the wrong number of data. It certainly would. Including statements inside the loop that belong outside the loop. What does that mean? Well, if this was inside my loop, it would print out, congrats, you managed to follow instructions, even when they got it wrong, right? If I tab that over, if I make it inside the loop, how do I know it's inside the loop? It's tabbed. Then when they got it wrong, and it got in here, it would print, congrats, you managed to follow instructions, even if they totally botched it on the second try too, because it's inside the loop. So you need to keep in mind that if it's printing out the total every time instead of only once at the end, or whatever, that it should have been outside the loop, so unindent it. Very easy mistake to make, really easy. I've made it up here while teaching. I see lots of students do it too. So most computer languages support a for. For loops are great for when the number of iterations is known. Seems like it should be R grammatically because of the S there, but of iteration modifies it, so you know, for the number is known. Anyways, so for loops, you get to specify a starting point, an end point, and a step. And then you put all of that in one line, and so you don't have to initialize your loop control variable in one line. You don't have to test in another and update in a third. Just makes it more reliable to write, for one thing. So in a post-test loop, the body executes once before the test. And we did a loop like that, right? Do some blah, 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 while x less than 5. So it's going to go and do the blah, 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 no matter what x equaled to begin with. That's because that was a post-test loop. We don't have to stress about post-test loops. We don't have them in Python. But there may be a question about it on the exam. I mean, on the on MindTap, and if so, just go back to the text and or the PowerPoint and find the answer. You can use loops to accumulate totals, like in business reports, or to reprompt the users for valid data. So in the selection structure, the two logical paths have to join back together. And selection can either, you have a diamond. If it's a selection, I don't know why they're going back to selection when this is loops, right? But if has got to go, back together. Doesn't matter what's here. It doesn't matter what's here. It's got to go back together. If it's a loop, it better not do that. It better jut off to the right and then go back up, or on top of it, like the book shows. And then there's only one way out. All right, gang. We are done. We're going to make some homework, and then I think we're going to end. So homework. Quote. Write a loop that adds summation and prints the total of all the numbers, whole numbers, right, between 10 and 100. So that's just starting at a different place, right? Rather than start at 1, start at 10. Write a loop that prints the numbers 20 through 40 by 2s. In other words, the step is 2. I have a hunch that this is kind of a duplicate of a prior assignment. Write a loop that asks for an age and gives an error message and loops gives an error message and asks them again if the age is less than 0. It should be a loop, not an if. The last homework did a negative loop as well, right? Count down from 10 to 1, something like that. Anybody done that homework yet? I guess I could look.